Have you ever worked on a coding project and ended up with files named finalversion.zip, finalversion2.zip, and final.zip? Or accidentally deleted important code and couldn't get it back? Or tried to work with a teammate on the same project and had no idea how to merge your changes? If you've experienced any of these frustrations, you've discovered why GitHub exists. GitHub is one of those tools that changes everything once you understand it. Welcome to this complete guide on GitHub for beginners. I'm going to explain what GitHub is, how it actually works, and why every single programmer, whether you're a student, a freelancer, or someone working at a tech company, needs to master this tool. Here's what makes GitHub so powerful: it solves all those problems I just mentioned. It tracks every change you make to your code, lets you go back to any previous version in seconds, and makes it incredibly easy to collaborate with other developers. By the end of this video, you're going to understand GitHub completely. You'll know how to create your first repository, make commits, work with branches, and understand why building a GitHub portfolio is one of the smartest things you can do for your programming career. Let's dive in. Before we talk about the solution, let's talk about the problem. And the problem is real. Picture this. You're building a website. You make changes and save. Then you make more changes and want to keep the old version just in case. So you save it as website backup.zip. Then you make more changes. Now you create website v2.zip. Then website v2 backup.zip. Then website v3 final.zip. Then website final do not delete.zip. Now your folder has 17 copies of the same project, and you have no idea which one is actually the current version. You're wasting hard drive space, you're confused, and if you delete the wrong file, you might lose weeks of work. Now imagine you're not working alone. You and a teammate are building the same feature. You both modify the same file. You send your version to your teammate. They send theirs to you. Now which version is correct? Did you overwrite their work? Did they overwrite yours? Which changes got lost? How do you know what actually changed between versions? This is a real problem in team development, and without a system, it creates chaos, lost work, and frustrated programmers. Here's another scenario. Your code was working fine 3 weeks ago. Now something is broken. But when did it break? What changed? Who made the change? Why did they make it? Without a system tracking every change, you're stuck guessing. You might spend hours debugging something that could be fixed in minutes if you could just see the project history. These problems frustrated programmers for decades until version control systems were invented. And GitHub is the platform that made version control accessible to everyone. Alright, let's clear up the biggest source of confusion for beginners. Two words that sound almost identical but mean completely different things: Git and GitHub. Git is a tool. GitHub is a platform. Let me explain each one clearly. Git is a version control system. That's a technical term, so let me break it down. Git is software that you install on your computer. Its job is to track every single change you make to your code files. Think of Git as a personal librarian for your code. This librarian sits on your computer and keeps a detailed record of every edit you make. The librarian never deletes anything. If you want to go back to how your code looked 3 weeks ago, the librarian can show you instantly. Git works locally. That means it's on your computer. You don't need the internet. You don't need to upload anything to a server. Git is just there, tracking your changes, saving checkpoints of your work. When you use Git, you create something called a repository. A repository is just a folder on your computer that contains all your project files plus Git's tracking information. Git watches that folder and records everything that happens to every file in it. GitHub is something completely different. GitHub is a platform. GitHub is a website. You go to github.com, create an account, and you get a place to store your code online. GitHub uses Git. But GitHub adds extra features on top of Git. GitHub lets you upload your Git repositories to the cloud. GitHub makes your code accessible from anywhere. GitHub lets other developers see your code. GitHub makes collaboration easy. Think of GitHub as a social network for programmers. You have a profile. You have repositories. Other developers can see your work, follow your projects, and contribute to them. Here's the key relationship: Git is the tool that tracks changes locally. GitHub is the platform where you share those tracked changes with others. Imagine Git as a personal diary where you write down everything you do. Imagine GitHub as posting that diary online so other people can read it, comment on it, and even contribute to it. You use Git on your computer. You push your Git work to GitHub. Other people pull from GitHub and get your latest work. GitHub stores everything safely in the cloud. If your computer crashes, your code is safe on GitHub. You might ask, why use both? Why not just use GitHub? Because you want version control locally, offline, fast. That's Git. And you want to share your code online, collaborate with others, and build a portfolio. That's GitHub. Together, Git plus GitHub creates a complete, professional development workflow. It's how every serious programmer and every company develops software. Now that you understand the relationship, let's dive into how they actually work. There are 6 core concepts you need to understand. Master these, and you understand Git and GitHub. First concept: repository. A repository is your project. It's a folder on your computer, or on GitHub, that contains all your project files plus Git's tracking data. Let's say you're building a web application. You create a folder called My Web App. Inside are all your code files, HTML files, CSS files, JavaScript files, images, whatever. You initialize Git in that folder, and now it becomes a Git repository. The repository stores not just your current files, but the entire history. Every version you've ever saved is recorded. Every change, every commit, every modification is permanently tracked. Repositories exist in 2 places. A local repository lives on your computer. A remote repository lives on GitHub servers. When you work on your local repository. When you want to share or back up, you push to the remote repository on GitHub. Second concept: commits. A commit is a checkpoint. It's a snapshot of your project at a specific moment in time. Let's say you're building that web application. You write some code to add a login feature. You test it. Everything works. Now you create a commit. This commit records what files changed, what lines of code were added, what lines were deleted, when this happened, who made the change, and a message explaining why. Think of commits like save points in a video game. You're exploring a level, and you find a safe place, so you save. If you get killed later, you can reload from that save point. With Git, if you make a mistake in your code, you can revert to a previous commit. Commits are the building blocks of version control. Your entire project history is just a series of commits, each one a snapshot, each one showing exactly what changed and why. Third concept: branches. A branch is a parallel line of development. This is incredibly powerful, and it takes some beginners a moment to grasp, so let me explain carefully. Imagine you're working on a web application. The current code is stable and working. It's the version you've deployed to actual users. You call this the main branch. Now you want to add a new feature, dark mode. But you don't want to mess with the current stable code while you're experimenting. So you create a new branch called Add Dark Mode. This branch is a complete copy of your main branch at this moment, but it's separate. Now you work on the dark mode feature in this branch. You make changes. You commit your work. You test. You add more features. Meanwhile, the main branch hasn't changed at all. It's still stable. Eventually, dark mode is working perfectly. You're confident it's ready. Now you merge your branch back into main. All your dark mode code is now part of the main branch. Why is this powerful? Because multiple developers can work on different branches at the same time. One developer works on dark mode. Another works on a notification system. A third works on payment processing. Nobody interferes with each other's code. Everybody's changes are isolated and safe until they're ready to merge. Branches make large-scale development possible. They prevent broken code from reaching users. They're one of Git's most powerful features. Fourth concept, push and pull. Push and pull are how you synchronize between your local repository and your remote repository on GitHub. Push means upload. You've made commits on your local computer. Now you want to upload those commits to GitHub. You push. Your commits move from your local repository to the remote repository on GitHub. Pull means download. Your teammate has pushed their commits to GitHub. You want the latest code. You pull. Their commits move from the remote repository on GitHub to your local repository. Push and pull keep everyone in sync. They're the communication mechanism between your local work and GitHub servers. Fifth concept, pull requests. A pull request is a proposal. It's a formal way to say I've made changes on my branch, and I'd like to merge them into the main branch. Here's the flow. You create a branch and make changes. You push to GitHub. You open a pull request. This PR includes a description of what you changed and why. Now other developers can review your code. They read through your changes. They might say, "Great work, but can you refactor this function?" or "I found a bug in this logic." You discuss. You make changes if needed. Once everyone agrees the code is good, the PR gets approved. Then it's merged. Your changes are officially part of the main branch. Pull requests are quality control. They're how professional teams maintain code quality. They're also how you learn. Senior developers review your code and teach you better practices. Sixth concept, forking. A fork is your own copy of someone else's repository. Let's say there's a popular open source project on GitHub that you admire. You want to contribute to it or learn from it. You fork it. This creates a complete copy under your GitHub account. Now you have your own copy. You can modify it, experiment, break things, whatever. You're not affecting the original project. If you make improvements and want to contribute them back to the original project, you create a pull request. The original project maintainers review your contribution. If they like it, they merge it. Now your code is part of the original project, and you've contributed to open source. Now let's walk through exactly what a developer does every single day. This is the complete workflow from start to finish. Step 1. Clone the repository. You need to work on a project. The project lives on GitHub. You clone it. Cloning means you download the entire project, including all its history, to your computer. You run a git command, and in seconds, the complete project appears on your local machine. You now have a local repository with everything. Step 2. Create a branch. You're not going to work on the main branch. That would be risky. The main branch should always be stable. Instead, you create a new branch for your feature. If you're adding a notification system, you might call it Add Notifications. If you're fixing a bug, you might call it Fix Login Bug. You create this branch, and now you're working on your isolated copy. Step 3. Make your changes. You open your code editor. You modify files. You implement your feature. You add new functions, new styles, new logic. You're actively developing. Step 4. Stage your changes. You've made a bunch of changes, but you don't want to commit all of them in one shot. Maybe some changes are related to your feature, and some are related to a bug fix. You want to keep them separate. You stage the changes you want to commit. This is like selecting which changes to include in your next save point. You tell Git these changes should go in my next commit, but not those changes. Step 5. Commit your changes. Now you create a commit. You've staged certain files. You write a clear message explaining what changed and why. Something like add email notification system to user dashboard. You hit commit. Git saves this snapshot. You might make several commits over time. Each commit is logical and well described. Step 6. Push to GitHub. Your commits are on your local machine. Now you upload them to GitHub. You push your branch to GitHub. Your commits are now on the remote repository. Step 7. Create a pull request. You go to GitHub's website. Your branch now has commits that main doesn't have. You create a pull request. This PR says, hey, I've made these changes on this branch, and I'd like to merge them into main. You write a description. You might explain what feature you added, what bugs you fixed, or what improvements you made. You request reviewers. Step 8. Code review. Other developers receive a notification that you've created a PR. They read through your code. They test your changes. They leave comments. Maybe they ask you to refactor something. Maybe they catch a bug. Maybe they say this is great, but can you add a comment here to explain this logic? You discuss back and forth. Step 9. Merge. The review is done. Everyone agrees the code is good. The pull request is approved. You click merge. Your changes are now officially part of the main branch. Your feature branch has served its purpose, so you delete it. Clean repositories are organized repositories. And then you repeat. This entire cycle repeats. Tomorrow, you create a new branch for a new feature. You make changes, commit, push, create a PR, get review, merge. This is how professional development works. Let me explain why you should care about GitHub beyond just using it for version control. Here's a truth that might surprise you. Many employers look at your GitHub profile before they look at your resume. Why? Because GitHub shows actual code you've written. It shows how you solve problems. It shows your coding style. It shows your ability to work with others. It shows your learning journey. An employer can see every project you've built. They can see your commit history, which shows consistency and dedication. They can see pull requests and code reviews, which shows collaboration skills. They can see documentation you've written, which shows communication skills. Your GitHub profile is proof. It's not just a claim on a resume that you know how to code. It's actual evidence. If you're just starting your programming career, you face a catch-22. Nobody will hire you without experience, but you can't get experience without being hired. GitHub solves this problem. You build projects on your own time. You push them to GitHub. You build a portfolio. An employer looks at your GitHub, sees 5 or 10 really well-built projects, and now they know you can code. I've seen fresh graduates and career changers land good jobs because they had a strong GitHub portfolio. It filled the experience gap. If you're already working as a developer, GitHub is where opportunities come from. Recruiters look at GitHub. Investors look at GitHub. Collaborators find you through GitHub. Contributing to open-source projects on GitHub builds your reputation. It shows you're engaged with the community. It shows you care about code quality. Senior engineers notice contributors and remember them. Think of GitHub as your digital portfolio. A fashion designer has a portfolio showing their designs. An architect has a portfolio showing their buildings. A developer's portfolio is GitHub. When I was hiring developers, I always asked to see their GitHub. The portfolios told me so much more than any interview question could. I could see their real skills, their judgment, their ability to write clean code, their consistency. And here's the key: you don't need permission from anyone to build a GitHub portfolio. You don't need a company to sponsor you. You don't need to apply. You just start building and pushing your projects today. Over time, as you contribute to projects, help others, and build a reputation, GitHub becomes an asset that opens doors. It's a public record of your growth as a developer. That's why learning GitHub early, even as a beginner, is one of the smartest investments you can make in your programming career. Enough theory. Let's get practical. Here's exactly how you start. Go to github.com, click Sign Up. Enter an email address. Create a password. Choose a username. Your username matters. You're going to share this with employers, colleagues, and the programming community. Don't use something silly or unprofessional. Something like your -name or if your name-dev is good. Something like XX programmer for 20XX is not. Once your account is created, fill out your profile. Add a profile picture. Add a bio. Add your location. Add a link to your website or portfolio if you have one. Make it professional. Click the plus icon and select New Repository. Give it a name. Make it descriptive. If you're building a to-do app, call it Todo-app. If you're learning Python, call it Python-learning or Python-projects. Add a description so people understand what the project is about. Select public so other people can see it. This is how you build your portfolio. Check the box to add a README file. The README is super important. It's the first thing people see. It should explain what your project does, how to use it, what technologies you used, and how to install it if applicable. Click Create. Your repository is now live on GitHub. Now you need to work on it locally. Clone it to your computer. In seconds, you have a local copy. Add your code files to the local repository folder. Maybe you're adding a website. Maybe a Python script. Maybe a mobile app. Whatever your project is, the files go here. You've made a bunch of changes. Stage your files. Create a commit with a message like initial project setup or add project files. Push to GitHub. Congratulations! Your code is now on GitHub. It's backed up. It's version controlled. It's visible to the world. From here, you keep building. You add features. You fix bugs. You create branches for each feature. You commit regularly with clear messages. Every project you build, push to GitHub. Eventually, you'll have 5, 10, 20 projects. That's a portfolio. That's evidence of your skills. That's valuable. Here are the commands you'll use most frequently. Git clone, download a repository. Git checkout-b, create a new branch. Git add, stage files. Git commit-m, create a commit. Git push, upload to GitHub. Git pull, download from GitHub. Git status, see what changed. That's it. These 6 commands cover 90% of what you do. You'll master them quickly with practice. Before you start, let me give you a cheat sheet of mistakes to avoid. Don't write update or fix or changes in your commit messages. Nobody knows what that means. Future you won't remember what that means. Instead, write add user authentication or fix memory leak in data processing or update documentation for API endpoints. Be specific. Write for someone reading this 6 months from now. Never push API keys, database passwords, or authentication tokens to GitHub. This is a security nightmare. Anyone can see your secrets and exploit them. Use .git ignore files to exclude sensitive files. Use environment variables. Keep secrets safe. Don't commit directly to main. Main should always have working code. Always create feature branches for your work. Keep main clean and stable. Don't change 50 files in one commit. It's hard to review. It's hard to understand what changed. It's hard to debug if something breaks. Make small, logical commits. Related changes grouped together. Changes focused on one feature or one bug fix. This makes your history readable and maintainable. When two branches change the same code, Git can't automatically merge. You get a merge conflict. Don't panic. Read the error message. Understand the conflict. Resolve it manually. Merge conflicts are normal. Learning to handle them is a skill. You've learned a lot. Let me summarize the key takeaways. GitHub is the industry standard for code management. It solves real problems. It enables collaboration. It tracks history. Version control isn't optional anymore. Every serious programmer, every serious company uses Git and GitHub. Learning GitHub early gives you a competitive advantage. It shows employers you're professional. It builds a portfolio. It opens doors to opportunities. Here's what you do next. Create a GitHub account today. Create your first repository. Push a project. Make commits. Build your portfolio. Eventually, contribute to open source. Be consistent. The great news? Everyone starts exactly where you are now. Every professional developer was once confused by Git and GitHub. With practice, it becomes natural. You've got the knowledge. Now go put it into practice. If this video helped, please like and subscribe. If you have questions, drop a comment. If you want to share your first GitHub project, I'd love to see it. Thanks for watching, and welcome to the GitHub community.